Hey Dalton, this is the lecture over the quadratic equations. That's the second part of your guided notes. Before we get started with all the ways to solve quadratic equations, we're just going to define what a quadratic equation is. And the definition of a quadratic equation is an equation that is equivalent to ax squared plus bx plus c equaling 0. So any equation that's equivalent to this. Now it doesn't have to look identical to this. But if we're given an equation that can be converted to be written in this format, we call that a quadratic equation. And typically we know it by the presence of an x squared. Now the first method to solve quadratics is factoring. In order to solve by factoring, we must set equal to 0. So in order to use this technique, it has to be in this format. There is no other format that doesn't work in order to do this. So in this first example, A, we have the GCF factoring method. GCF stands for greatest common factor. And it involves, before we back up here in just a second, we're going to use what's called the zero product property, which says if A times B is equal to 0, if you give me two numbers, A and B, that multiply to equal 0, the only way that can happen is if A is equal to 0 or if B is equal to 0. The only way to multiply two numbers and get 0 is if one of those two numbers is 0. So either A is 0 or B is 0. So that's why we're going to use factoring. Factoring is the process of rewriting an expression as a multiplication of two other expressions. So to do the GCF method, we're going to first set it equal to 0. We have to set it equal to 0, that way we can take advantage of this zero product property. So to get this set equal to 0, we're going to minus the 6x over. X squared minus 6x equals 0. And then we're going to factor out what they have in common. X squared and 6x both have the presence of an x. So we're going to take an x out. X squared divided by x is x. And 6x divided by x is just 6. And then now we have two things being multiplied equal to 0. Therefore we can say, well, that means x is equal to 0, or x minus 6 is equal to 0. Adding that 6 over gives us x would equal 6. So our two answers to this equation are 0 and 6. Now the difference of squares method. The difference of squares deals with when you have two perfect squares, a squared and b squared, that are being subtracted, hence difference of squares. And it's always going to factor to a plus b times a minus b. And we can see that this is true by foiling this out. A times a is a squared. A times negative b is negative ab. B times a is positive ab. And b times negative b is negative b squared. These will cancel, leaving us with a squared minus b squared. So we're going to take advantage of this rule and complete this problem. Now 27 and 48 cannot be square rooted. They're not perfect squares. However, we can always fall back to the GCF method. 27 and 48 can both be divided by 3. If we divide this entire equation by 3, we get 9x squared, take away 16 is equal to 0. Now, 9x squared can be square rooted. The square root of 9x squared is 3x. 16 can be square rooted. The square root of 16 is 4. So according to this rule, two perfect squares subtracted is equal to the square roots added and the square root subtracted. So this will factor to 3x plus 4 times 3x minus 4. Now once again, we're going to apply the zero product property. Two things multiplied equaling to 0 means either 3x plus 4 has to equal 0 or 3x minus 4 has to equal 0. Giving us that x is either equal to negative 4/3 if you solve this equation, or x is equal to positive 4/3 if you solve the other equation. So that's our second factoring method, and it's called the difference of squares method. Now, for trinomials where a is equal to 1, we see that this is a trinomial because it has three terms, and we know that a is equal to 1 because the numerical constant in front of x squared is 1. And remember, a is the value attached to x squared. So first off, though, we're going to get this equal to 0. So we're going to minus the 18 over. x squared plus 7x minus 18 equal to 0. And when we have a trinomial where a is equal to 1, we want to find the factors of c. In this case, c is negative 18, that have a sum of b. In this case, b is 7. So factors of 18, well, how do we multiply to get 18? Well, we've got 1 times 18, we have 2 times 9, we have 3 times 6. Now we need to use these numbers in some way to get the number 7. 1 and 18 we cannot use to get 7, 3 and 6 cannot. We can get a 7 using a negative 2 and a positive 9. Therefore, this is going to factor into two binomials that both start with x, because x times x makes x squared. And then these two values, negative 2 and 9, will be what we fill in the binomials with. So we have a negative 2 and a positive 9. And if we were to FOIL this back out, we would verify that it equals x squared plus 7x minus 18. Zero product property. If we set both of these equal to 0, we would get x is either equal to 2, or we would get x is equal to negative 9. Alright, and then lastly, the last factoring method, the method that you may have not learned the way I'm going to show, and if you have learned a different way to do this method than what I'm going to show, that is okay also. But this is typically how I show it, and it's called factor by grouping. And this is for trinomials where a does not equal 1. Okay, so that's specifically important. And we can see that this is an example of that because there's a 2 in front of the x squared. But in any case, we're going to minus the x over, and we're going to minus 3 over. And when we get this in standard form, we see that it matches the definition of a quadratic equation, and we have a not equaling 1. So when that happens, we have to find the factors of not just c, but a times c, that have a sum of b. So in this case, a is 2 times c is negative 3. So you have to find the factors of negative 6 that have a sum of negative 1. The value in front of this x would be a negative 1. So the factors of 6 are 1 and 6, 2 and 3. We can't make a 1 with 1 and 6, but we can make a negative 1 if we use a 2 and a negative 3. Now, the difference between this method, method D, if you will, and method C is we cannot jump straight to 2 parentheses because x times x does not make 2x squared. So what we do is we split this up. This would be 2x squared. We would bring down the minus 3, and we're going to split the middle term up into 2x from the 2 here minus 3x. And so we use the 2 and negative 3 to fill in these two slots. And then since the 2 is positive, we're going to put a plus sign here. And then we do what's called factor by grouping. So we're going to group the first two. And when we group the first two, we're then going to apply the GCF method. We take out what they have in common. They both can be divided by 2x. Dividing 2x squared by 2x gives us x. Dividing 2x by 2x gives us the quantity 1. Now if we group the second two, negative 3x minus 3, we can divide those both by negative 3. Dividing negative 3x by negative 3 gives us x. Dividing negative 3 by negative 3 gives us a positive 1. And what we can see is we have two expressions. We have 2x times x plus 1 minus 3 times x plus 1. They have an x plus 1 in common, so that's GCF method again. Therefore, we can bring the x plus 1 to the front, and that would leave us with 2x minus 3. I'm not going to write out setting these both equal to 0 because I'm about out of room, but if you were to set this first one equal to 0 and solve, you get negative 1. If you were to solve the second one equal to 0 and solve, you would get 3/2. Alright, Dalton, for the second method to solve quadratics, we're going to use what's called the square root method. And the square root method just says if x squared is equal to p, where p is a number that's bigger than 0, because we can't square root a negative number, so therefore p either has to be positive, bigger than 0, or equal to 0. Then x can either equal the square root of p, or x could be the negative square root of p. We don't know which one. So as an example, just real quick over here, if I were to say x squared is equal to 4, well, to get rid of the square, we square root. But since we're squaring a number to get 4, well, that could be 2, but it could also be negative 2, because both of those numbers squared gives us 4. So we don't know which one is the answer, so we just list both of them. And that's what the square root method is implied by. So on this one here, x squared is equal to 5. We're going to square root both sides, meaning that x could either equal the square root of 5, or x could equal the negative of the square root of 5. Now the square root of 5 is an irrational number, and it doesn't simplify. So that's our answers. We would stop right there. Now in the second example here, we can see that the square root applies because there's presence of just an x and the quantity squared. There's not an x squared and an x presence. So we would solve this like we would a regular equation. So we're going to minus the 6 over, and we get 3 times x minus 2 squared is equal to 27. And then we have this quantity 3 out here that we would have to divide over, and we would get that x minus 2 squared is equal to 9. Now, to get to the x, we have to go through the minus 2 and the squared the outermost object. So to get rid of that, we're going to square root, which means x minus 2 could be 3, but x minus 2 could also be negative 3, because the square root of 9 is 3 or negative 3. And then in both of these cases, we're going to add 2 over, and we get that x could equal 5, and we're going to add 2 over here, which says x could equal negative 1. So our two possible answers for this equation is 5 and negative 1. Now one thing, this is an extra example that's not in your guided notes. I wanted to go over this one. When we solve this, we would square root both sides, and we would get x could equal radical 20, or x could equal negative radical 20. Now square root of 20 is not a perfect square. It doesn't simplify down to a whole number, but the radical does simplify. I'm not for sure how you learn to simplify radicals, but there's two ways. Method 1 is we use our perfect squares, 4, 9, 16, 25, 36. All the numbers such that when we square root them, we get a whole number. And we figure out which of these goes into 20. What's the biggest one that goes into 20? Well, 4 goes into 20. 9 does not. 16 does not. 25 is too much, so we're done. So 4 goes into 20 5 times. So we're going to rewrite 20 as 4 times 5, which then can be written as the square root of 4 times the square root of 5. And we know that the square root of 4 is 2. So the answer is 2 radical 5. And then obviously this would be negative 2 radical 5. Now that's one way to simplify radicals, and that might have been how you learned it. But then here's a second way that some people find it to be a preference. But it involves using a factor tree. So 20 breaks down into 2 times 10. 2 is a prime number, so we circle it. 10 breaks down into 2 times 5. Those are both prime numbers. And then from there, we can see that the square root of 20 can be written as the square root of the square root of 2 squared, because 2 times 2 makes 2 squared, times 5. And a square root and a square will cancel each other out. So the square root of 2 squared times the square root of 5. And these will cancel out, leaving you with 2 radical 5. And for a shortcut, here's how I usually teach my students. I say, for a shortcut, if it appears twice inside of a factor tree, it goes on the outside. If it only appears once in the factor tree, it stays on the inside of the radical. But in either case, that's how we simplify radicals. I just want to make sure that you're comfortable with doing that also. I think there's 2 more methods. There's completing the square for a quadratic, and then there's also the quadratic formula. I think I want to wait and do those with another video. That way we can keep the videos for less than 15 minutes. And Dalton, if you feel that these videos are taking you a little bit more time than this to get through, just let me know, and we can figure out, we'll get something worked out. So just keep in touch. If you have any questions about the video, let me know, and I will talk to you later.